All right, welcome to another quantitative literacy lesson. Here we have lesson 2.4, how crowded are we? So main objectives here are looking at population density, which is the ratio of the number of people in a given area to the area. Population density may be described proportionately to compare populations. So we're going to calculate some densities and compare them. So let's take a look at an example. It could be, imagine 100 people standing in a parking lot that's 20 feet by 20 feet, okay? So the people are spaced so that each person stands in a 2-foot square. Population density could be thought of as 100 per 400 square feet, right? Because 20 times 20 is 400. That reduces down from 100 over 400 to 1 over 4, which I've written out here. So we have one person. 2 times 2 is 4 square feet. Okay? Now, if you take 1 and divide by 4, you get 0.25, but the units are still persons per square foot. So we could either say there's 1 person per 4 square feet, or there's 2.5 persons per 1 square foot. Okay? The second version is what's called the unit ratio, where we did the division and the denominator is 1. So we're going to take a look at that next. So let's take a look at a group of people in a classroom. And how about we have, say, 10 people. And we're just going to take a small corner of the room. So maybe we grab a part of the room that is 10 feet by 10 feet. Okay. So imagine a row of desks. You could fit 10 people in a row of a grid of desks that's 10 by 10. People would be sitting next to each other. You'd have a tiny bit of elbow room. Maybe this is like people in a movie theater. We just get a bunch of people and stand them in the corner of the room. So if we have an area that's 10 feet by 10 feet, multiplying those dimensions together is going to give me the area. So 10 times 10 is 100. Feet times feet could either be called feet squared, or we could write it as square feet, which I'm going to abbreviate as SQ for square, FT for feet there. So as far as the density goes, density is just the number of people divided by the area. And in this case, we have 10 people divided by 100 square feet. Now, 10 over 100 reduces nicely, so I could say that's 1 person for every 10 square feet. So 10 square feet, let's see, 3 feet times 3 feet is 9, so that's a little bigger than a 3 by 3 grid all to yourself. So think about that, look down at the floor, imagine what 3 feet by 3 feet looks like, and then a whole bunch of people standing next to you in similar boundaries. 1 divided by 10 I could write as a decimal, right? So I could say that's 1/10, 0.10 people per square foot. Oops, people per square foot. So here I've written it as a unit rate because there's no more denominator. Right? So there's a bunch of ways we can describe this particular population density. Let's see what comes next. So now we're going to calculate population density based on a larger rectangle. So in the classroom that I usually teach in, it's about 25 feet by 25 feet. And so if you multiply 25 by 25, I think on a good day that is 625, and that would be square feet. Let's just grab a calculator to double check. Hopefully you have a calculator right now playing around. Here's my calculator. So I want to take 25 times 25. Yeah, 625. And we take that same group of 10 people. So now we have a different density here, right? So the density in this case, which is again people per area, in this case area is square feet, we have 10 people divided by 625 square feet. We could reduce this a bit. If we divided top and bottom by 10, for example, we would get 1 persons. Dividing this by 10 just shifts the decimal, gives me 62.5 feet squared. So let's see. 7 times 7 is 49, 8 times 8 is 64. So this means each person gets their own 8 foot by 8 foot square to live in. So if we took our room and we divided that up into 8 foot by 8 foot chunks, each person gets one of those 8 foot chunks. That becomes your little cubicle to live in. If we continue this division by whipping out a calculator, let's get that calculator back. So we take our 10 people and divide by the 625 square feet they have to share. Then we get, let's see, tenths, 100,000, 16 thousandths. So as a unit rate, this becomes 0.016 people per square foot. Okay, so that's just a little tiny bit of a person in 1 square foot. So let's see, maybe that's about 1 of my feet in a square foot. So if I lay down in my rectangle, 1 of my feet gets to take up that much of a square foot. Kind of weird idea, but that's the way we do it. So in this example over here, where I put 1 in the numerator, by dividing out the numerator, I divided top and bottom by 10, I get the amount of square foot 1 person gets. When I carry out the full division, dividing the 2 numbers, I get the fraction of people per square foot. Now, sometimes instead of square feet, we do square miles, right? So let's think about square mile density for this group of people here. What would that be like? So I'm gonna, before I do the next questions, let's take a look. New page. Oops, not next page. New page. There we go. So there are 5,280 feet in 1 mile. So if I want to change that to square miles, I have to square both of these. So I have to figure out what is 5,280 times 5,280. Calculator. Raised to the 2nd power gives me, let's see, I can't highlight that. There we go. 1, 2, 3, 1, 2, 3. So it's 27,878,400. Can I remember that? Can I copy it? Let's see what happens here. Doesn't paste in. Okay, so let's see if I remember that right. So if I square that number, I got, darn it, 2 million. No, 27 million. Okay. I got it this time. So 27,878,400 square feet live in 1 square mile. And we had a ratio of 0.016, 16 thousandths people per square foot. Right, that was our unit rate that we got at the end there. So I want to do a conversion here where I get rid of feet squared, so it has to go on the top, squared, so square miles has to go on the bottom. 1 square mile is that 27,878,400. So this tells me that if I want to convert per square foot to per mile, I would have to multiply by that 27 million number times my fraction of people in a square foot. All right, let's check that out. Desktop, calculate. So I want to take that. I want to multiply by 16 thousandths. And that gives me, about 446. Wow. square miles. No, 446. Oh, that's right. This is people, right? So 446,054-ish, 0.4. I think I got that in my head. So new number is 4460, oops, 5. That decimal point does not belong there. How's my eraser work? It's not the eraser. Oh, no. Undo. Whew. Do I have a little eraser? Let's try that one. That's better. All right, 54.4, and that is people per square mile in this case. Or mile squared, whichever you prefer. All right, so in the room it doesn't seem too crowded, but in a square mile, 400,000 people. What is that like? Huh? I'm curious. What does that really mean? Let's think about something. I live in the town of Pendleton. Let's check out Pendleton. Let's see, did I put that over here? So I looked up Pendleton, Oregon on Wikipedia. And well, let me blow this up. Nope. Let's see, it says Pendleton has a total area of about 10.5 square miles. And there are almost 17,000 people in Pendleton. And somebody's been kind enough to calculate the density here for me, which is 1,000, oh, it's almost 1,600 people per square mile. So just a note on that, switch back here. Nope, wrong button. How about that button? There we go. So just for a comparison, let's pick a color. Compare this to the city I live in of Pendleton, Oregon. And Pendleton has a density, according to Wikipedia, of approximately 16,000 people per square mile. So again, this number right here, the 446,000 people per square mile, came from us putting 10 people in a room that was 25 feet by 25 feet. Okay, so imagine a classroom of that size, 10 people in there. It's not too crowded. Now, imagine all 10 people living in that space and having to do stuff. Then it's going to feel a little bit crowded, right? Bedroom, bathroom, kitchen kind of stuff, all crammed in there with 10 people. That's going to be an interesting living condition for the standards we have in the United States. Something to think about. Population density. Our classroom is way more dense on average than the people living in the town of Pendleton. All right, let's go back here. So now we consider 1 million people, each in their own 2 foot by 2 foot square. Now remember, up in the example above here, 62 is close to 64. So this density right here, each person would live in roughly their own 8 foot by 8 foot square, which in a classroom setting seems pretty spacious. But in terms of living in a town or city is not so spacious. So 2 foot by 2 foot square for each person. So that means the density for one person, right? Each person is in their own 2 foot by 2 foot square. So we have one person per 2 times 2 is 4 square feet. If we want to scale that up by 1 million, that means 1 million people, multiply the top by a million people. Well, we have to keep these equal. We have to multiply by the bottom by a million. So 4 times a million would be just 4 million feet squared. However, we would want to rewrite this in the standard way we talk about population densities in the US, which is people per square mile. So we've got a little bit of work to do on that. So we need a conversion here where we get rid of feet squared and we convert to miles squared. And that value was 27,878,400 feet squared. Eek. It's a whole lot of feet squared. So 27,878,400 per one. Right? Now, if you think about this multiplication right here, this fraction reduces to 1/4. So basically, we want to know what is 1/4 of that 27 million number. So, calculator, there you are. So clear. So I want to know what is 1 divided by 4 times 27,878,400. And I get, let's see, what do I get here? 1, 2, 3, 6,969,600 people. So 6969600. Color. So that is 6969600 people per mile squared. Okay. So compare that to that classroom we had. It is here we had what, 400,000 people in a square mile. That would be people having an 8-foot by 8-foot space each based on that density up there. Here we crammed people tighter in their own 2-foot by 2-foot square, so no elbow room, work like shoulder to shoulder pretty much. So you can fit a lot more people in a square mile. Okay. So now we're just going to do that again. What if we had each person with their own 100-foot by 100-foot square? So thinking about the area I live in, I have some of the houses live in lots that are 100 by 100. The lot I live in is 50 feet by 100 feet, so that's more room than I have now for my house and my yard. It's like twice as much as I have, but some of my neighbors have that much, and some have more, and some have less. So maybe on average, each person in town maybe has their own 100-foot by 100-foot square. Let's see. So the density in this case, each person, right, each of us has 100-foot by 100-foot. So our density in this situation, density is 1 people per 100 by 100. So 100 by 100. So that would be 10,000 square feet that we each have to work with. Calculating that per square mile is just like we did in the last two examples. We're just going to multiply that by 27,878,400, because that is the number of feet in square feet in 1 square mile. Okay? So 1/10,000th of this. Hey, wait, we can just shift by zeros, right? It's a nice trick with division of powers of 10. So there's 1, 2, 3, 4 zeros. So that means over here I can shift the decimal point. Let's switch colors. 1, 2, 3, 4 places. So the decimal is going to go there. So we should get 2,787.84. See, we canceled out square feet. That leaves people per mile squared. Okay. So now there's only about almost, roughly 3,000 people per square mile, versus over here we had 7 million people per square mile. So that was a 2 by 2 foot square. If we each had our own 8-foot by 8-foot square, that was like 400,000 people per square mile. So this density right here is closer to Pendleton. Pendleton had, I think it was 1,600 people per square mile. Okay? So each person having their own 100-foot by 100-foot square is a little more dense than Pendleton. Think about most towns, though, taking into account streets, taking into account parks, taking into account businesses that we all go to. And so that drops the density down because all of those streets, businesses, and parks take up area, but you have the same number of people in there. So that's going to drop the density, so you have a bigger denominator. All right, fun stuff with densities. Moving on. So next we're going to compare the US to China. We did that a little bit with smokers before with that data. In 2010, the US had approximately 300 million people and about almost 4 million square miles of land. In China, it was 1,300,000-ish people, and they lived on just a little less land. China is slightly smaller than the US. Okay? So you can imagine, let's see, we have about the same size land area, but China has more people. So 3 million versus 13 million, which is another way to, sorry, I said that wrong. 300 million versus, say, 1,300 million. There we go. That's right. So just, roughing it out, China is more dense because they have more people on about the same amount of land. So a student carefully calculates the population densities of China and the US. He decides that China is less dense than the United States. Use your estimation skills to decide if you think the student is correct. Show your reasoning. Okay. So again, my reasoning here would be the student is incorrect because he says China is less dense. China is more dense. So somehow there was a mistake in the student's calculation because China has more people in about the same area. At a lecture, you hear someone claim that in terms of population, China is more than 4 times as dense as the United States. Oh, okay, that's interesting. Let's see. If we just talk about millions, 300 million, 1,300 million, 3 times, let's see, what did he claim here? 4 times. What's 4 times 3? 4 times 3 is 12. Here I have 13. Hey, that might be reasonable, right? We could calculate these densities to double check. So here I think statement A is incorrect. China is more dense, not less dense. And I think statement B is correct. I'm betting it is about 12 times more dense because China has 4 times more dense because China has about 4 times more people. All right, let's do these calculations. So on your calculator, you want to check out China versus the US. And for each of these, we're going to have a population. We're going to have an area. And based on the population and area, we can calculate density. All right, so basically, I can make a beautiful table out of this information. So China had what? 1,339,190,000 people and an area of 3,705,000 square feet. So this is population, area, square miles. And actually the rest of the world measures in square kilometers, not square miles. So keep that in mind. Density would just be the division of these two. All right, so let's see if I can get that right on my calculator. Calculator, there you are. Let's clear you. So we have a population of 1,339,190,000 divided by an area. Let's see if I get that right. Thousands, millions, billions. Yep. And we want to divide that by, go away, messenger, stop it. 3,705,000 square miles. So China's density is about 361-ish, is what we can report back. So 361, and that again is people per mile squared. All right, United States. Can you guys see those messages popping up? Somebody wants my attention. All right, United States is, let's see, what was that? That was 300. I didn't write it down. I have it over here. 3 million, no, oh, there we go, 309,975. Okay, so 309,975. So double check. thousands, millions. Yep. Okay. Divided by 3 million, was it 317,000? 3,717,000. 717,000 gives me a density of about 83-ish. So we had this. We should have had a spreadsheet on this, shouldn't we? We'll try that next. So population was 309,975,000. Acreage or area in miles, excuse me, not acreage, is 3,717,000. And we divide them, we get about 81-ish people per mile squared. So if I want to compare how much more dense is China, I would take the China density and divide by the US density, which would be 360-ish divided by, let's call that 80. Or we could do 81, no big whoop, because we have a calculator. So, 83, not 81, fix that in a sec. So 360 divided by 83, and we get about a little over 4, about 4 1/3 times more. So this was supposed to be an 83, and so we get about 4.3 times more dense. All right, there is one more question for you to consider here, and I'm going to leave that up to you. Explain how the statements Anchorage has more than 40% of the Alaskan population, and Ketchikan is the most dense population state in Alaska. How can both of these be correct? Let me know. So take care, do good math, have fun. See you soon.